In this lesson, we are discussing lines. We're going to talk about several different ways to write the equation of a line, how to graph a line, and how to find the slope of a line, along with parallel and perpendicular lines. Alright, so first, starting out, the slope is just the rate of change. Rise over run, as you're used to thinking about it. You're taking the change in the y's over the change in the x's. That's what that delta triangle sign means. And then our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you're finding the change in the y's over the change in the x's. Here I have Mr. Slope Dude, so we're going to talk about the different types of slopes you can have. So first, when we rise from left to right, that's a positive slope. When you fall from left to right, that's a negative slope. Vertical lines have an undefined slope. And horizontal lines is like walking on a flat surface. They have zero slope. So, if you have a positive slope in your graphing, when you're done graphing, you should make sure your line rises from left to right, or else you graphed it incorrectly. Same thing, maybe undefined, 0. Make sure your graphs match what they're supposed to look like. So here we're asked to find the slopes of the 4 lines. Notice point P is the same for all of them. We have different point Q's, Q1, 2, 3, and 4, and we're going to find the slope of each one. So remember, make sure you're subtracting your y's on top first. So M is going to equal negative 2 minus 3 over negative 1 minus 2. That simplifies to negative 5 over negative 3. And that equals positive 5/3. So the slope of line 1 is positive 5/3. So when graphed, it should look similar to that. For line 2, we're going to take negative 1 minus 3 over 3 minus 2, which is negative 4 over 1, which simplifies to negative 4. For line 3, we take 3 minus 3, that would be the change in the y's, over 5 minus 2 is the change in the x's. That gives you 0 divided by 3, which is a slope of 0. And then last here, for line 4, change in the y's is 5 minus 3, over the changes in the x's, which is 2 minus 2. That's 2 divided by 0, which you cannot do. So that is an undefined slope. Alright, so when graphing lines, we're going to draw a graph of the line that contains the point 3, 2 and has these 2 different slopes. So when you're given a point, use that point. So go ahead and plot the point 3, 2. And then from that point, we're going to use the slope of 3/4. And if we're rise over run, since it's positive, we're going to go from that point up 3, right 4. Or you can go down 3, left 4 to keep it a positive slope. So up 3, right 4. Or down 3, left 4. And you can connect your points. So that's what the graph for the slope of 3/4 through the point 3, 2 looks like. Same thing for the next one. We're going to go through the point 3, 2. So there's my point 3, 2. From that point, my slope is negative 4/5. So since it's negative, I can go up 4 and left 5. Or I can go down 4 and right 5. So negative 4/5. I can go up 4, left 5. Or that's the same thing as going down 4, right 5. And there you have your graphs. Next, we're asked to graph the equation x equals 3. So this time we don't have a specific point to plot and a slope to use, but we're told that x is 3. So if x is 3, go on your graph where x is 3. So an x-intercept of 3. Well, x is also 3 at any point on that vertical line. X is always equal to 3. So that is what the graph looks like. And if x equals some number a, that will always represent the x-intercept with 0 slope. So it's always going to be a vertical line with not 0 slope, with undefined slope. All right. All right. Moving on, we're getting into the different forms. So point slope form, that is y minus y sub 1 equals m times x minus x sub 1. M is representing the slope. Y sub 1 is representing the y coordinate of a point. X sub 1 is representing the x coordinate of a point. So here we're asked to find the point slope form of an equation of the line with a slope of 4, so m is 4, containing the point 1, 2, so that's going to be our x1, y1. So if you're given a point and the slope, you can always use point slope form. So plugging that in here is going to be y minus 2 equals 4 times x minus 1. There's no simplifying to do. That is the equation in point slope form. Next here it says find an equation of the horizontal line containing the point 3, 2. So we have a point, x1, y1. There's no slope directly given to us, but it tells us it's a horizontal line. So that means our slope is 0. So if I plug that in, I'm going to have y minus 2 equals 0 times x minus 3. I am going to simplify this just to show you something. Y minus 2 equals 0. So y equals 2. So a horizontal line will always be y equals some number b. It always represents the y-intercept with 0 slope. Okay, so if you have an equation y equals whatever, it's always going to have 0 slope, be a horizontal line, and it's representing the y-intercept. Okay, next, slope-intercept form is one commonly used. It's y equals mx plus b. And from that, m is representing our slope, b is representing our y-intercept, and we can easily graph from that as well. So here we're asked to find the slope m and the y-intercept b of the equation. 2x plus 4y equals 8, and graph the equation. Well, if you're asked to find the slope and the y-intercept, you want to get it into slope-intercept form, which is where y is by itself. So here we want to get y by itself, so we're going to subtract 2x from both sides. So 4y equals, I put the negative 2x first, plus 8, because that's the form. Divide everything by 4. And we get y equals negative 1/2 x plus 2. So our slope is negative 1/2. Our y-intercept is 2. So I'm going to plot the y-intercept 2. And from there I'm going to go down 1, right 2. Down 1, right 2. That's the same thing as going up 1, left 2. And you can connect to make your straight line. And there you have your graph. Next, for us to find the equation of the line containing points 2, 3, and -4, -5, and graph the line. Okay. If we're using slope-intercept form, you have to have the slope. If you're using point-slope form, you have to have the slope. So, regardless of what type of equation we're doing here, we have 2 points. We need to know what the slope is. So let's use the slope formula to find the slope. You're going to take -5 minus 3 over -4 minus 2. That's -8 over -6, which is positive 4/3. So the slope of the line is positive 4/3. Now that we have the slope, we can use that and any point given to plug into y equals mx plus b in order to find b. Or you could use point slope form and simplify. It really doesn't matter. Since I haven't done the y-intercept form yet, I'll do it right here. So I'm going to use 2, 3 since there's no negatives. So it's going to be my xy. So I'm going to do 3 equals 4/3 times 2 plus b. That's 3 equals 8/3 plus b. And when you solve for b, you get b is equal to 1/3. So we know what m is, we know what b is, so our final step is to write y equals mx plus b using those. So y equals 4/3 x plus 1/3. Now, it's going to be hard to graph a y-intercept of 1/3 and using a slope of 4/3. So just use the 2 points that were given to us. So we were given 2, 3. And we were given -4, -5. You only really need 2 points to make a line, so that's what we'll go with. And you can see it looks like it's hard to tell, but the y-intercept is probably 1/3. Let me check our slope. Up 4, 1, 2, 3, 4. Right, 1, 2, 3. Looks like it checks out. Okay, our last form here is the general form. This one has some restrictions on it, per se. The form is ax plus by equals c, where a and b cannot equal 0, a cannot be negative, and a, b, and c are all integers, so that you can't have fractions or decimals. If you do, we will have to get rid of those. Alright, so here we're asked to graph the equation 2x plus 4y equals 8 by finding its intercepts. So our x-intercept, remember we plug in 0 for y. 2x plus 4 times 0 equals 8. That's 2x equals 8. So x is 4. So 4, 0 is the x-intercept. Our y-intercept then, plug in 0 for x. That's 4y equals 8. So y equals 2. So 0, 2 is the y-intercept. Plot those 2 points and connect, and you are good. Okay, last things we have here are parallel and perpendicular lines. So two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Okay, so here, parallel lines, slopes are equal. That should make sense because if two lines are going to never cross, they have to rise and run by the same amount, or else they would eventually cross. So here we're asked to show that these two lines are parallel. So in order to do that, I need to show that their slopes are the same. And to see their slopes, I need them in slope-intercept form. So I'm going to take each and rewrite them. Subtract 2x. So 3y equals negative 2x plus 6. Divide everything by 3. Y equals negative 2/3 x plus 2. So that first equation has a slope of negative 2/3. Doing the same thing to this equation, we get 6y equals negative 4x. Divided by 6. We get y equals negative 2/3 x. Its y-intercept is 0. So these two lines are parallel. Because they have the same slope of negative 2/3 and different y-intercepts. Here we're asked to find an equation for the line that contains the point 2, negative 3 and is parallel to the line 2x plus y equals 6. So we have the point that it goes through, and we're told that it's parallel to this line. That's important to know so we can find the slope we need. So I'm going to rewrite this so I can find its slope. Y equals negative 2x plus 6. So negative 2 is the slope of this line. Our line is parallel, so we will also use a slope of negative 2 because parallel lines have the same slope. So we're going to do, you can write it in slope-intercept form or point slope and simplify. I'm going to do point slope this time. Y minus negative 3 equals negative 2 times x minus 2. That's y plus 3 equals, if I distribute, I get negative 2x plus 4. And that would give me y equals negative 2x plus 1 as my equation. And then last here we have perpendicular lines. So by definition, it says two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. That's just saying that their slopes are opposite reciprocal of each other. So for example, the opposite reciprocal of negative 2/3 is positive 3/2. So opposite signs flip their fraction form. So last example, find an equation of the line that contains the point 1, negative 2 and is perpendicular to x plus 3y equals 6. Graph the two lines. Okay, so first I'm going to take this x plus 3y equals 6 and write it as y equals mx plus b. So 3y equals negative x plus 6. Divide everything by 3. Y equals negative 1/3 x plus 2. So the slope of this line is negative 1/3. But our line is perpendicular to that. So we need to use the opposite reciprocal, which would be positive 3. So again, I'm going to use point slope form. I'm going to take y minus negative 2 equals 3 times x minus 1. That's y plus 2 equals 3x minus 3. Subtract 2 from both sides. Y equals 3x minus 5 is my equation. When I graph it, I can start at negative 5 on the y-axis. And my slope is 3, so I'm going to go up 3. And I run 1 because it's technically over 1. And then the other y-intercept is 2. And its slope is negative 1/3, so we're going to go down 1, right 3. And connect those. And those are perpendicular, meaning they make a right angle right there at all 4 corners. And that is it for lines.